Hello everyone, today we're going to continue with monomials, but this time with some more exercises. These are going to be concentrated on the theory part we did in the last video, so it's not anything too practical, we'll just remember some theory topics. So this is going to be in a layout similar to a quiz, so because it's more theoretical. But in the following videos, we'll also see some operations and something that is more common to see in maybe a test or homework assignment or anything else. But let's start with this question. The expression 2m over n is not a monomial, while 2m over 3 is. Why? So I'll reveal the answer in 3, 2, 1. Okay, so in the first expression, we are dividing by n, which is a letter. And if you remember, in a monomial, we cannot divide with letters. So 2m over n is not a monomial by definition. While the second one is dividing by a constant, which is a number that is 3. So in this case, it's like saying 2 over 3 times n. And 2 over 3 is a quantity, it's a number. We have multiplication, so this is definitely a monomial. There is no problem with that division because it's with a number, not with a letter. That is the problem. Now let's go to the following question. Of course, if you want to answer before me, just stop the video and think about that question. Second question. Only one of these is a monomial. So remember, we are talking about monomials, not anything too fancy yet. So just concentrate on this that we talked about in the last video. So letter A, 3ab over x. Letter B, 2. Letter C, x minus 2. Letter D, 2ab to the negative 1. E, negative xy plus a. So I'll show the answer in 3, 2, 1. Here it is. So letter B is correct. So why is letter B correct? In the last video we said that also numbers can be considered monomials. And we also said that the null monomial is 0, okay, which is a number indeed. Let's see the other options for completeness. So letter A, 3ab over x. As we said before, here we are dividing by a letter, which is x. And by definition, this cannot be a monomial, okay? Then letter B is correct. Letter C, x minus 2. Here, we are subtracting a quantity from another quantity, which is x. And this is not a monomial, because monomials only have multiplication and exponentiation, which basically is also a form of multiplication. And when we have exponentiation on letters, these exponents must be natural numbers and positive. This is why natural numbers are integers, which are positive. So we restrict the numbers we're working with exponents. So in this case, we have subtraction, it's not multiplication, so this is not a monomial. Letter D, 2ab to the negative 1. As I just said, the exponents on letters, remember, on letters, this is important, must be natural numbers. So b to the negative 1 is like saying 2a over b, basically, and so it's not a monomial by definition. That negative 1 is what's wrong with this. Then last but not least, letter E, negative xy plus a. Here we have multiplication, but we also have addition. And this is not allowed for monomials. Now, next question. Reduce the following monomial to normal form. So if you don't remember what normal form is, you can either go back and check out the last video, or you can see the solution of this and just work out and try to understand what we're doing. So I'll start explaining the answer in 3, 2, 1. Okay, so when we want to reduce to normal form, we want to do the multiplications. This is really important. We are just going to do some calculations. It's not that much harder. We're going to see this more specifically in the next video, but I wanted to introduce this because I think that you can do it pretty easily if you have a solid arithmetic base. Now, what we're doing here is just putting the coefficients one next to the other so that we can do our calculations more easily, and putting the letter B with the other letters. Now, we're going to do this multiplication, and we see that we get 4/6, which can be simplified to -2/3. Now, we're going to do basically the same thing we did in the first step, because we're going to multiply the coefficients. So 2 times 2 is 4, and 3 times 1 it would be is equal to 3. So we have -4/3 as for our coefficient. And then we're going to do the multiplication with the letters. So in this case, we need to sum up the exponents. I remind you that when we don't have an exponent, this means that the number is 1. So here we have 1, here we have 1, and here we have 1. So we need to do, in order to find the solution, for A, 2 plus 1, which is 3. For B, 1 plus 1, which is 2. And for X, 2 plus 4, which is 6. So our final solution is -4/3 a to the cube b squared x to the 6th. Next question. Which of the following expressions represents a third-degree monomial? So letter A, 5x squared y x cubed. Letter B, 2abx squared. Letter C, -2x to the -2. Letter D, abc. Letter E, 2ax squared y. I'll show the answer in 3, 2, 1. So letter D is correct, because I remind you that when we don't have an exponent, it means that the number is 1. So the exponent of A is 1, the exponent of B is also 1, and the exponent of C is also 1. So the overall degree is the sum of the degrees of the letters. And so we need to do 1 plus 1 plus 1, which is 3. So it's a third-degree monomial. Now, let's have a look at the other options for completeness. Letter A. In this case, we need to do 2 plus 1 plus 3. So this is clearly greater than 3, because we are adding to the quantity 3 another quantity, so it's going to be greater. Then, letter B, we're going to do 1 plus 1 plus 2, which is 4, and is greater than 3. Letter C, this isn't a monomial whatsoever. It's -2, so we don't consider this because it's not a monomial. Then letter D is correct. Letter E. Here we're going to do 1 plus 2 plus 1, which is also a fourth-degree monomial, which is not correct because we're looking for a third-degree monomial. Now, last questions. It's a true or false. I will show the answer after each letter. Okay, so when I complete the first one, I will show the answer. When I complete B, I will show the answer, and so on. So the degree of the monomial 2 to the cube a squared b to the 4th is 6. I'll show the answer in 3, 2, 1. True, this is true. Why is this true? Because the degree of a monomial is only, we need to sum only the exponents of the letters. We cannot count the exponent of the constant. 2 to the third would be 8. Okay, so in this case we need to do 2 plus 4, which is indeed 6. So the exponent on the number must not be considered when dealing with degrees of a monomial. Then, letter B. In the monomial 5xy squared, the degree respect to x is 1. I'll show the answer in 3, 2, 1. This is also true, because recall that when we do not have a number on the exponent, then we can infer that the number is 1. Okay, so in this case the exponent, and so the degree with respect to x, is 1. Letter C. In the monomial 2x squared y to the cube, the degree respect to the letter z is 0. I'll show the answer in 3, 2, 1. This is true. Why? Because if we have z to the 0, this would be equal to 1. Okay, so if we multiply 2x squared y to the cube by 1, we will still get 2x squared y to the cube. So it is right to assert that the exponent, and so the degree with respect to the letter z, is indeed 0. Okay? Then the last question. The degree of a monomial is the product of the exponents of the letters. I'll show the answer in 3, 2, 1. False. This is definitely false. The degree of a monomial, in fact, as we saw also with the other questions, is the sum of the exponents, not the product. So we don't need to do the multiplication, but we need to sum those. For example, in the first exercise we did 2 plus 4, which is 6. Okay, doing 2 times 4 would be equal to 8, which is wrong. Okay, the degree of a monomial is the sum of the exponents of the letters. Okay, so I hope this video was helpful. I hope I didn't rush too much through this, but anyway, if you feel like I did, please comment in the comment section below if you have some questions. So see you in the next video. Bye.